Alright, and next up, section 12.2. Ooh, scrolling off the page. Alright, we'll fix this real quick. Law of cosines. So we got ourselves a dinosaur walking around. So big dinosaur walks and his footprints will make a triangle. What we're going to use here is the law of cosines to be able to find out more about this triangle. We can use the law of cosines specifically in any situation where we know two side measures and the angle that's between those sides. Or if you just happen to know only the three sides of a triangle, we can use the law of cosines to find an unknown angle. Alright, so these are actually both the same equation, it's just manipulated in two different ways. On the left-hand side here, we can use this if I'm trying to find a missing side. So for that, I would need to know what two of the sides are, and I would need to know what angle A is. So again, we could say, like, if this is A, this side is little a. If angle C, angle B, little b. That same equation can be used, though, in a different form if we manipulated it around. If I'm trying to find the unknown angle of a triangle, cosine A equals the two known sides, b squared plus c squared, minus angle A. Notice their relationship here, all over 2bc. Alright, so we're going to use one for finding an angle, one for finding a measurement. So I'm going to use the law of cosines here to find the step angle, or to find this angle right here to find angle B. So I'm looking for angle B, so cosine of B equals a squared plus c squared minus b squared all over 2ac. So if this is angle A, side A, so 155 squared plus lowercase c, or 197 squared, minus 316 squared, all over 2 times 155 times 197. Alright, so we're going to have to use our calculator here, because I cannot multiply all these in my head. But that's going to get us, scroll down a little here, that's going to get us 24025 plus 38,809 minus 99856 all over 61070. When we add all those out and divide as needed, our cosine value for cosine B would be negative 0.606222. Alright, but we still have this cosine here. We need to be able to find the angle. You need to take the inverse cosine of the angle. So in your calculator, cosine inverse of point negative 606,222 will give us, for an answer, angle B as 127.32 degrees. So unlike the law of sines, law of cosines here, plug in all our numbers. There's a lot more work in terms of multiplying and squaring and using our calculator. However, on a good note, it can be used in all the situations, and you don't have to go through that theoretical how many triangles are there. So a couple examples right here. First example, finding x. Well, for this triangle, I need to know which angles are which. So I'm just going to label this A, angle B, angle C, little c. So I'm looking for side A, or a squared. That's going to be, from our other side, a squared will equal b squared plus c squared minus 2bc cosine of angle A. Alright, this will get me 11 squared plus 12 squared minus 2 times 11 times 12 times the cosine of 22 degrees. Or 121 plus 144 minus 264 times the cosine of 22 degrees. Let's make sure our calculators are in degrees. Alright, when we combine all those, we get 20.2235 for our a squared. Take the square root of the other side, we have 4.497, or about 4.5 for our distance. For the second example, it just says to solve triangle XYC. Solving it, that means I need to find out what all three angles are. They gave me the three sides, but I need to find the three angles. Alright, so I'm going to treat this the way I did it. Think about if this was a, that'd be little a. I know it's z and x and y, but it still works in the same manner. So if I'm looking for the cosine of y, that would be 17 squared plus 15 squared, because this is essentially b and c right here, minus 23 squared all over 2 times 17 times 15. So if we thought about this as b and c for our formulas from the front, again we get the cosine of y equals 289 plus 225 minus 529 all over 510, or the cosine of y will be equal to negative 0.029412. Type in the inverse into our calculator and angle y will come out to be 91.69 degrees. So now we know what one of the angles are. I'm going to have to repeat that same process here, and I'm running out of room. So that's our first angle right there. Now I'm going to just erase a little bit of this so I have some room to do the next one. So I write too big. So now to find the cosine of z, we would then have to do 15 squared plus 23 squared minus 17 squared all over 2 times 15 times 23. And that's going to eventually give me the cosine of z equal to 0.673913. When I use my calculator to take the inverse of that, or cosine to the negative 1 as it looks like, we get 47.63 degrees for z. Now I know what z is. Y we found out earlier to be 91.69. So when I subtract each of those from 180, that'll get me my final angle x as 40.68 degrees. Alright, so those are two example problems there for you. We got one more down below for you, so you can just hit pause on the video, and we'll show some work here in just 1 second. Alright, and now, last but not least, this is the U-try. So here's all your work right here. I use the law of cosines to find that side A is 20.6. And after I can use that, I'm going to actually take it back to the last section and use the law of sines to be able to find sine of B is equal to 0.7095. Take the inverse to find angle B as 45.2 degrees. Now I know what angle B is. I know what angle A is that was given to me. I can subtract from 180 to find angle C. So that is the law of cosines. Hopefully it's a little more straightforward and simple for you than you thought the last section was.